Alrighty, so let's see. Okay, so now we're doing the exciting second part of this guy, right? So the meatball leaves the edge of the table with a purely horizontal velocity. We're definitely going to use that, right? But it's not landing on the table because now we're talking about when it's gone down 0.8 meters, right? Okay, so we're not going to use that. Let's see what we know. I feel like we know these guys. I think we know, if we always know these guys, right? We know this guy. And then I think that down 0.8 meters, we know that, right? All right, so this guy's 0. This is negative 9.81. 1.35 must be our horizontal velocity for the whole time, right? Because there's no acceleration, right? We're ignoring air friction or any jet propulsion, right? Has a purely horizontal velocity, right? So this means there's no vertical, right? And then it goes down 0.800. So down, that's what minus is, right? It's negative because it's down, right? All right, and then I think we can solve this, right? And then we can just go over it like that, right? So it's gone down that far. Basically, it's just like solving it again, and we're saying the cliff is that tall. But let's figure this out. Okay. And we want to know the position and the velocity as both in components and an angle magnitude vector. Okay. So how far out, how far down? Okay, so we can do this. I'm going to use v squared is u squared plus 2as. So the absolute value of v is the square root of 0 squared plus 2 times negative 9.81 times negative 0.8. All right, I can do this. The square root of 2 times negative 9.81 times negative 0.8. I'm going to store that somewhere. How about in the variable v? All right, hold on here. Oh yeah, there we go. Okay. I'm getting 3.9618. And of course, we're going to choose that it's going down that speed. Because these are cliff problems, right? Everything goes down, right? All right, and then the time, I'm going to choose this formula, S is ut plus 1/2 at squared to find the time. That's my favorite, right? So negative 0.800. The initial velocity is, of course, 0, so it's just 1/2 negative, sorry, 9.81 times t squared. Okay, let's do this. 2 times 0.8 divided by 9.81. That's 0.40386 roughly. Seconds, right? That's seconds, not a 5. And then that, of course, we can fill this guy in too, right? 0.40386. And then we can find in the vertical direction, we can go S is ut. And that's it, right? The 1/2 at squared isn't there because there's no acceleration, right? So it's 1.35 times 0.40386 roughly, right? I just rounded that to 5 sig figs. All right, let's see. So times 1.35. All right, and so that displacement is 0.54520 meters. All right, so let's see if we can answer the questions. What is the position? Well, how far out, how far down? Well, it's very far out, right? It is 0.545 meters out. I'll just call that in the x direction, right? And then, of course, if we went down 0.8 meters, we're down 0.8 meters, right? All right. That is our position. We are out and down. All right. And then we want the velocity in components, right? So that would be these guys. All right, so the velocity components are 1.35 meters per second in the x direction, plus, and then that's negative 3.96 meters per second in the y direction. So that is components, right? And then if we have to draw that as an angle magnitude vector, that's over and down. So that's 1.35, right? And this guy is 3.9618. And the magnitude's going to be 1.35 squared plus 3.9618 squared. All right, I can do this. All right. Okay, so the square root of 1.35 squared plus, I just stored that in the variable v. Whoops, I got to square the v though. Okay. I'm getting 4.1855. That's a 4. 4.1855, so I guess 4.19 meters per second. And then we got to find this angle here, right? So that angle is going to be tan minus 1 of 3.9618 over 1.35. All right. Second tan of that guy divided by 71.2 degrees. 71.2 degrees. All right. All right. So there we go, right? So in how far out, how far down, there's the answer, right? That far over, that far down. The velocity is as components, right? As an angle magnitude vector, you draw this, you label that angle 71.2 degrees. You draw this with arrows, you're good.